Alright, problem number 8 on the study guide. We want to completely solve the triangle with these three side lengths. So draw yourself a little diagram, usually makes things easier. Let's go A, B, and C. Side A will be opposite angle A, so that side's going to be 1.53. Side B, opposite angle B, so that side's going to be 0.65. And side C, opposite angle C, so we're going to get 1.2. Now we're going to need to use the law of cosines, which is c squared equals a squared plus b squared minus 2ab cosine of angle c. You could rewrite that in any form. You could put a squared first or b squared first. The options abound, but remember, the key to law of cosines success is that we want to find the angle opposite of our largest side. We want to find the largest angle first. So remember, largest side goes with largest angle, so we're going to start with angle A. If it helps you, you could rewrite this a squared equals b squared plus c squared minus 2bc cosine of A. It really doesn't matter. You just got to understand how the equation works to plug it in. So let's get going. So a squared, which is 1.53 squared, equals the other 2 squared, 1.2 squared, plus 0.65 squared, minus 2 times those values, 1.2 and 0.65, times the cosine of angle A. So now we need to work backwards. We need to get the cosine of A by itself. So to do that, let's subtract these two squared terms. So we're going to get 1.53 squared minus 1.2 squared minus 6.65 squared equals negative 2 times 1.2 times 0.65 cosine of A. Law of cosines is big and messy, but it is totally useful, and it's not that bad. You just have to be careful. So let's get the cosine of A by itself. To do that, we're going to divide both sides by that whole lot there. So we're going to get 1.53 squared minus 1.2 squared minus 0.65 squared divided by negative 2 times 1.2 times 0.65. And that's going to equal the cosine of A. So if I want A, I need to take the inverse cosine of all of that. Boom. Throw it all inside there. And plug that into your calculator. You should get the value. A should be 107.858 degrees, which tells us that our diagram is straight crazy. This triangle should be looking more like something like that. A big old angle, 107.858. So something like that. And, make it close. It doesn't matter. Again, I could continue with the other triangle. It makes absolutely no difference. I'm still going to have angle A, angle B, angle C, and then the same side lengths, 1.53, 0.65, and 1.2. Nothing changes. You really don't need to redraw your diagram. I just did it because I'm being a punk. Still clearly not a good diagram, but whatever. So now that we have one side length and an opposite angle, we can use law of sines. So let's use law of sines to find angle C. So sine of C divided by the opposite side, which is 1.2, equals the sine of angle A, which we just found, 107.858, divided by 1.53. So multiply by 1.2 on both sides. You'll lose it over there. We get sine C is going to equal that. So take the inverse sine of both sides, and you will get C equals the inverse sine, or the arc sine, of all of that mess. Plug it into your calculator. You should get C equals 48.29 degrees. So then to get B, all we have to do is 180 minus 107.858 minus 48.29. Do that and you should find B is 23.852 degrees. And we're done. That triangle done been solved.